everyone, welcome to week 2 of NR 220 range, also known as measurements week. This week we're going to learn how to assess rangeland condition. So I'm your quote-unquote host this week. I'm actually the range instructor for section 4, but I've put together these materials for week 2. If you're in session 4, you probably already know me, but if you're in sessions 1, 2, or 3, maybe you don't. And if you'd like to look up my instructor introduction, you can find that if you wish. So let's get started. First, our goals for this week are going to be to introduce a new concept to you. That's the concept of plant succession. And we're going to, along the way, review a few of the concepts that were introduced last week. And by the end of this module, by the end of this week, you're going to learn how to use your newly found botanical prowess, your skills of plant ID, and what you're going to learn today about plant succession in order to evaluate the health of a rangeland. And so we're also, along the way, we're going to keep practicing our plant ID skills because it's very important, not only in practical life, but also for you in passing this class. And we know that by week 2, you don't have every single plant mastered. So we're going to try and help facilitating you and improving your identification ability. Okay, today we're going to be talking about rangelands and change, and really how, why, when rangelands change, and maybe what some of those important drivers are of change in rangeland systems. But in order to do that, we first need to recognize that rangelands are inherently dynamic ecosystems. And really that shouldn't come as a surprise to anyone, because what ecosystem isn't a dynamic ecosystem, right? But something I'd like you to keep in the back of your mind is that change can happen on a variety of scales. So when we're specifically talking about rangelands and short-term changes, we might think about daily or weekly changes. And an example of that might be a plant that is not blooming this week, may be in bloom the following week. We can also have seasonal changes, so differences in the plant community between summer, spring, winter, fall. You might think of your warm versus cool season grasses as an example of that. We can also have interannual changes, and this is probably the best example would be differences in the plant community that might appear on the landscape as a result of differences in precipitation that you might get from year to year. And if we're talking most long-term, or on the longest time scale, we're going to be talking about successional changes. So what is succession? Succession is defined as the orderly and predictable change in plant communities over time. And by change, we mean both plant species composition and changes in the community processes that are associated with those species. So if you take a look down here at this diagram, you can see an illustrated example of what we're talking about. This is an example ecosystem. It could be anywhere in the eastern United States, really, where you can find oak and hickory hardwood forests. So we're starting off here, you might say, really at the beginning of time. So this is with bare rock, no soil, and no plant life. And you can see that the first thing to colonize are going to be the lichens. These are part of the pioneer species. And we call them pioneer species because they're the first ones in, basically. They're the first ones to colonize. So after lichens and after a small amount of soil is formed, you're going to start to see small annual plants. These are plants that have shallow root systems and that are going to establish easily from seed. From there, we're going to transition into perennials, perennial forbs and grasses. These are plants that are more permanent herbaceous plants. They have deep root systems. From there, we start transitioning into what's termed as the intermediate species. And this is where you're going to start to see shrubs intermixed with those forbs and grasses. And in this particular example, you're going to see shade intolerant pines. Finally, When we transition out of those intermediate species, we reach the climax community. And this is defined, the climax community is defined as the presumed endpoint of the system, where once it reaches this state, the system is going to no longer change unless some sort of disturbance is introduced, some sort of disturbance is introduced from outside the system. Okay, so in this example, this community is made up of shade-tolerant oaks and hickories, and that's the presumed endpoint for this example community. But I would say the most important thing to remember, from this example, is that these changes are predictable. So depending on where you are in the world or what ecological community you're in, you can predict how the plant community is going to change over time. And what you observe on the land will tell you where you are along this continuum. So when we're talking about succession, we can categorize it into two types, and that is primary and secondary. Primary succession occurs when we have fresh substrates, when we're starting from virgin bare ground. That illustrated example I gave in the previous slide is an example of primary succession because it starts at that bare ground state. So probably the most commonly given example of primary succession are volcanic islands or volcanic island building. And if you think about it, you're creating a completely new piece of ground. There's no plants that exist on it. No life has existed on it before. It's brand new. Maybe more relevant to us in the Rocky Mountains is that glacial retreat can also result in primary succession. So if you think about it, as the glacier melts, it's exposing new material that's previously uncolonized by plants. And from there, the plant colonization process can start from the very beginning. Secondary succession is most commonly what we find ourselves assessing in rangeland science. So primary succession is rare, but secondary succession happens all the time. It occurs on a landscape that's been previously colonized by plants and following a disturbance. So here are some examples of a wildfire and clear cutting, examples of disturbance. And it looks like, both of these systems are in the west, and both of them were probably in a climax state before this disturbance was introduced. But after the disturbance, the system was set back, and probably both of these communities are going to be set back to a stage where they're going to be colonized by annual plants, weedy plants. So if you think back to our diagram, that's pretty far back on the successional timeline. Before we move on, I want to define a little bit of terminology for you. I touched on some of these terms already, but I want to clearly define them for you. So the first is seral stage. Seral stage is a specific community on a site at a given point in time. So both pioneer and climax are types of seral stages or examples of seral stages. When we talk about seral stages, typically we're going to use a terminology that uses the terms early to late on the successional timeline. So the pioneer stage, as I alluded to earlier, is an initial seral stage. It's going to be an early seral stage. The climax stage, or the climax community, is the theorized endpoint of succession. It's the latest or the final stage. So some properties about that are that one, it's self-perpetuating. It's in a self-perpetuating steady state, and two, that it's in equilibrium with the environment. So what that means is that, in theory, it will remain there in perpetuity unless a source of disturbance is applied to that landscape. This graph represents the primary successional model. On the x-axis, we have time. On the y-axis is the early to late seral stage. So as time progresses, of course, our plant community in blue moves along that predicted, theorized successional path that's represented in red. Now let's suppose that this plant community has progressed until the point where it's reached this climax community, or it's reached the potential natural community, and then a disturbance is introduced. It doesn't matter what kind of disturbance it is. It could be a fire, it could be a clear cutting, tornado, even a bulldozer, whatever it is. This disturbance sets back succession. It causes a retrogression. That's what that process is called, retrogression of succession. It changes our plant community to an earlier seral stage. following that disturbance and the retrogression, secondary succession occurs. So barring any other major disturbance, the plant community will again start progressing towards that climax community. And this is what's known as secondary succession. Now, how reasonable is it to think that successional changes are going to follow a smooth, completely predictable path towards that climax community? Well, given the fact that I started off this lecture by reminding you that rangelands are dynamic ecosystems, that should give you some idea of the answer. It's not very reasonable. So minor sources of disturbance are going to occur all the time. Resources are going to change over time, and so that's going to cause changes in the plant community. And in fact, some disturbances that are applied to the plant community can be so great that they set the community on a completely different pathway from the one that it previously occupied. So just keep in mind that this isn't always a smooth, linear, 100% predictable process. We tend to categorize plants in terms of how they respond to grazing pressure, whether they are increasers, decreasers, or invaders. Now, I know Rick introduced these terms to you last week, and as we'll see in a little bit, this is helpful for thinking about succession and the plant community. But first, why the focus on grazing? Well, for one, all rangelands are grazed, whether it's domestic animals or wild animals, as Rick said, everything from grasshoppers to moose. So if grazing is such a natural phenomenon, is it actually labeled as a disturbance? I would argue yes, although there is some debate and maybe different schools of thought regarding this, but I would argue that disturbance is a natural part of any ecosystem. We see that in different forests with trees that are adapted to different fire return intervals, and we see that in rangelands that are adapted to different forms of grazing. So grazing is a disturbance in that animals are removing plant material, they're at the same time trampling plant material, and disturbing the soil, which is going to favor some plants over others. Decreasers are plants that decrease in abundance when the ecosystem is disturbed. So some characteristics of these plants are that they are the dominant species at climax or climax stage. They also tend to be highly palatable and sensitive to grazing and other disturbance. They also tend to have an elevated growing point. So they're generally taller, and if you think about it, that's going to make them a little bit more sensitive, a little bit more vulnerable to trampling by grazing animals. Some examples that we're going to see today in the data collection and that are also on your list are Festuca idahoensis and Danthonia perrii, both native bunch grasses. Increasers are plants that initially increase in abundance when the ecosystem is disturbed. So I'll explain that a little bit more in depth in the next slides. But characteristics of these plants are that they are of moderate palatability, they have a lower growing point when compared to the decreasers, and they have the ability to recover quickly from grazing or other forms of disturbance. So some plants on your list that are good examples of increasers are Bouteloa gracilis, or blue grama, Chrysopsis villosa, and Antenaria parvifolia. Invaders are plants that occur after extreme disturbance, and so they're not commonly found on the landscape. But some characteristics, well, I should say they're not commonly found on the landscape unless there's a high level of recurring disturbance. And some characteristics of these plants is that they're often low palatability. They're often introduced, although they can be native invaders. And they're often annual or biennial. So some examples of invader plants on your list are Bromus tectorum. It's a really common invasive species across the western United States, cheatgrass. Bromus inermis, or smooth brome, and Potentilla fruticosa. That's actually a native plant, but it can be a native invader on some sites. So what do you think? Can we use these categories, decreasers, increasers, or invaders, to describe how plants respond to many different types of disturbance or other land uses in addition to grazing? And the answer I would say is yes, and that's because a lot of the different types of disturbance mechanisms are the same, regardless of the source of the disturbance. So, for example, on mountain campus, the primary form of disturbance tends to be students, in more ways than just the plant life on campus, but students tend to act as grazers in that they're removing the plant material, they're collecting specimens for identification, things like that, and they're certainly trampling it. which we all are. We need to walk around. But both of those mechanisms are mechanisms of grazing disturbance. So in that way, that's just an example of how a lot of the activities that we do as humans can have the same sorts of impacts on the plant community as domestic cattle or even any other large herbivore. Now, switching gears, how do we apply this knowledge of the plant community to be able to assess rangeland condition? Well, rangeland condition is simply a comparison of the present species on the landscape to the potential species composition for a given site. The potential species composition is that you would expect to find on the site if it is at the climax stage. So these range condition classes are kind of broken down into 4 very general categories. Using the traditional terminology, those categories are excellent, good, fair, and poor. Using more up-to-date, probably more helpful terminology, those categories correspond to the potential natural community, or PNC, late seral stage, mid seral, and early seral. So I'm presenting the old terminology here as well because you will still see it used sometimes, but we're going to talk a little bit more about why the newer terminology is preferable in some later slides. So the way that we break this down is on range condition is by collecting data on the present community's similarity to what the plant species composition would be at climax. So 76 to 100% similarity is going to be categorized as PNC. 51 to 75% similarity is going to be categorized as late seral. 26 to 50% similarity is going to be categorized as mid seral, and anything less than 25 is going to be categorized as early seral. Here's an example of range condition for an ecological site, a dry mountain meadow ecological site, and you can see that the percent of each species, or what we would call the percent species composition, that you would find at climax or PNC is presented here. So now let's take a look at how those percentages differ between the categories that we've just went over, so the decreasers, increasers, and invaders. And you're going to find that the decreasers are the most abundant, followed by the increasers, and then the invaders. So, in fact, this is a general principle that we can apply across all classifications of range condition and on all ecological sites. So, in this graph, we have the percent species composition on the y-axis and percent similarity to climax stage on the x-axis, as well as the disturbance influence from low to high. So at PNC, decreasers are going to dominate, followed by increasers, and invaders are going to be at very low abundance. As we move into the late seral stage, decreasers will be less abundant, compared to the PNC. However, they're still probably going to dominate that species composition. But as you move into the mid-seral category, you're going to see an increase in the increasers and invaders. And by the mid-seral category, increasers are going to start to dominate that species composition. As the site trends towards the early seral stage, the invaders are going to start to dominate. And again, these changes in plant community composition are going to be driven by that disturbance influence. The first step in assessing rangeland condition is to first determine the area where you want to do the assessment, right? That makes a lot of sense. Officially, these areas are going to be defined as range sites or ecological sites. So a range site or ecological site is a distinct type of rangeland that differs in its potential native plant species composition and, importantly, its response to management. And so if you know what ecological site your area that you want to determine the rangeland condition of is classified in, then you know what the potential native plant species composition should be. So the factors that go into determining what an ecological site is are the climate, soils, and topography. And that's just because, if you think about it, these are the factors that determine where certain plant species grow and what that plant species community is going to look